this is lab 4. It has to do with determining gravity on an angle. And the way we're going to demonstrate that is with a cart on this ramp, and we're going to start off with a small degree of slope, have the cart on an angle, and then increase the heights of the slope. As you know from previous labs, the acceleration due to gravity is 9.8 when you drop something straight down. And when you have the cart flat like this, the acceleration due to gravity is 0. But what is it in between positions? Now, what we're doing here in this lab is we're using a motion detector, putting it here at the end of the lab, and we're using a cart. We're going to run the cart down this ramp. We have a block underneath it. It's about 3 centimeters, a little bit less. And what we're going to find out is, from our computer, is what the acceleration of the cart due to gravity is on a very small angle. And we release the cart. It runs down. I have this little tail on it so that the motion detector can pick it up. And if you look here on the screen, here under our V over T graph, this red line is the motion of the cart. If we highlight that area and hit linear fit, you're going to see linear fit, the slope is somewhere around 1.7 meters per second squared. So what that's saying, at a small angle, commensurate with 2.7 centimeters, the acceleration of a cart due to gravity will be about 0.2 meters per second squared. And now what we do in the lab is we start to add blocks. And we eventually get 5 centimeters, then 8 centimeters, then 10, then 12. And we come up again with acceleration at all those angles. And all of the angles represent less than 10 degree angle. And we find in all cases, of course, gravity is going to be less than 9.8 and significantly less, because our formula is acceleration equals gravity times the sine of theta. Theta is the angle. If theta was 30 degrees, the sine of theta is 0.5, so A would be 4.9. We're talking at angles between 0 and 10 degrees, so it's going to be a great deal less than 4.9. And in this case, theta is going to be approximately 2 degrees, and the acceleration is going to be approximately 0.2.